Hello and welcome to the part 1 of the two-part lesson on Add Local Sizing Task. Ansys Fluent is the industry-leading fluid simulation software known for its advanced physics modeling capabilities and industry-leading accuracy. Before starting the simulation in Ansys Fluent, the geometry is required to be meshed with acceptable quality. Preparing a high-quality CFD mesh can be a very time-consuming and challenging task. But this can be done with ease using Ansys Fluent's Watertight Geometry workflow meshing, which greatly reduces hands-on meshing time and enhances efficiency. It has a guided workflow which makes meshing simple and intuitive. In this lesson, we will discuss about the import geometry task with focus on CAD import and edge, face and body sizing size control types available under the Add Local Sizing task of the Ansys Fluent's Watertight Geometry workflow meshing. So, without further delay, let's get started. Launch Ansys Fluent in meshing mode and start a new Watertight Geometry workflow in Ansys Fluent meshing. In the import geometry task, there are two file import options available. The CAD import, which starts from a CAD geometry, and the mesh import, which starts either from an existing surface or volume mesh file or an Ansys Fluent case file. Here, we will focus on the CAD import. An important requirement for using the watertight workflow is that the CAD geometry must be relatively clean with watertight regions. Clean CAD refers to error-free geometries, whereas watertight CADs refer to geometries with no gaps, holes, or leaks. The CAD geometries used in the watertight workflow can be a single body part or a combination of multiple bodies. The CAD import type supports any combination of fluid and or solid bodies. In addition to solid and fluid volumes, the watertight workflow also supports importing of geometries with voids. When dealing with multi-body parts, each of the bodies, fluid or solid, should be individually watertight. It is recommended that the shared topology operation is performed on geometries involving multiple bodies. Finally, it is recommended to group surfaces and create labels before importing the geometry into Ansys Fluent meshing. These labels are useful for adding local sizes and are subsequently identified by Ansys Fluent when assigning boundary conditions during the simulation stage. For import geometry units, we have different units available here. Here, we will select mm for units as the geometry has been prepared in millimeter unit. Once done, click import to load the CAD into the workflow. Once the geometry is successfully imported, turn on Insert Clipping Planes in the Clipping Planes section of the ribbon and select Limit by Z. We can now see the inside of our geometry where we have 3 square boxes enclosed by a larger box. The next task is the Add Local Sizing. Local sizing refers to the set of instructions related to mesh sizing given to the meshing algorithm to apply to specific parts of the geometry or localized regions. Local sizing is extremely helpful at the surface mesh level to ensure all the necessary geometrical features are appropriately resolved. It is also required at the volume mesh level to not only capture the fluid flow features that occur over a wide range of length scales, but also to resolve strong gradients in the flow field, such as in the wake of an object. Changing the "Would you like to add local sizing" option to yes enables you to define the local sizing controls. As mentioned earlier, we will be looking at the edge, face and body size controls of the Add Local Sizing task. Let's now start with the face size. In the Add Local Sizing section, under Size Control Type, select Face Size. The Face Size control type lets the user specify the size of the mesh that is applied on the selected surfaces of the geometry. This is specified in the target mesh size input box. In our case, let's use 1 mm. Note that all local sizing control types are soft sizings, meaning that the target mesh size value defines the maximum mesh size for the selected surface or region. It is possible for the mesh to be smaller than the target size depending on the other sizing settings. Let us select the body to faces surface. Notice that the boxes are overlaid onto the selected surface in the graphics window. This is the dynamic preview of target mesh size that will be imposed on the surface because of employing face size control. As you change the target mesh size, the sizes of boxes also change accordingly. You can use the Clear Preview button to erase the size boxes and select the target mesh size input box to redraw them. To entirely stop the dynamic preview, uncheck the Draw Size Boxes option. The final option that we need to discuss here is the growth rate. Growth rate defines the rate at which the mesh size increases away from the selected entity. This parameter becomes critical when generating the volume mesh. The default value of 1.2 is sufficient for most problems. However, for accurately resolving certain flow phenomena like laminar turbulent transition or when performing scale resolved simulations like LES, it is recommended to use a growth rate of 1.1 or less. Since we have defined all the necessary settings, click on Add Local Sizing to confirm the local sizing control. Let us now discuss the edge size and body size controls. As the names suggest, edge sizing refers to a local sizing control that is specified on the edges of the geometry, and body sizing refers to the local sizing control that is specified on bodies or closed volumes. The edge sizing control is only visible when there are named selections that have been defined for one or more edges of the geometry. Other than the difference in the type of entity being picked, all other options and settings are identical to the face size control. However, the impact each of these controls will have on the surface and final volume mesh is different. Note that we can define as many local sizings as needed on different surfaces or regions with different settings and of different control types. In the workflow, add 2 more local sizing controls, an edge sizing for body 1 edges region and a body sizing for body 3 body region, both with a target mesh size of 1 mm. Now that the 3 controls are defined, go to the Generate Surface Mesh task. Leave all the settings to default and click Generate Surface Mesh. Here is the surface mesh you should obtain. Body 1 shows a starkly different mesh distribution compared to body 2 and body 3. This is simply because the local sizing is specified only for the edges of this body. At the surface mesh level, the influence of both face and body sizing looks identical. Let us now go through the workflow and create a volume mesh. Other than changing the geometry type to, the geometry consists of both fluid and solid regions and or voids in the Describe Geometry task. You can keep the default settings and values for the rest of the tasks and execute each one of them till the Generate the Volume Mesh task. In the Generate the Volume Mesh task, select Polyhex Core for the Fill With option and click the Generate the Volume Mesh button. Here is the generated volume mesh. Now you can vividly see the difference between the 3 sizing controls. The edge size and the face size controls have the mesh clustered only near the edges and the faces respectively. Whereas, because of applying the body size control, all the cells inside body 3 have been created with the same cell size. We can also notice the effect of the growth rate by looking at how the local sizing propagates inside and outside the cubes. By using a lower value like 1.1 in all local sizing, we can see how the transition is delayed. This brings us to the end of this lesson. Let's summarize what we have learned in this lesson. We learned why meshing is required and what Ansys Fluent meshing watertight geometry workflow is. Then, we learned about the import geometry task and the geometry requirements of watertight geometry workflow. Finally, we discussed about the add local sizing task and edge, face and body size control type options available inside it. With that, let's wrap up the lesson.